All right, guys, so we're moving on into Unit 2. This is the multiple choice part A help video. So once again, just going to go through a few problems to help you guys do your exercises, and let's begin. So we're going to be skipping the first question. The answer is C. But let's go ahead and move on to question 2 here. It says, let G be this function here. Selected values of G are given in the table below. If the table values are used to approximate G prime of 1.5, what is the difference between the approximation and the actual value of G prime of 1.5? So they want us to estimate G of 1.5 using the table, and then they want us to do the actual value. All right, well, let's begin with the estimation. G prime of 1.5 can be estimated anytime you're using a table by picking two numbers that are really close to 1.5, and lo and behold, that's what those are. And so it's going to be G of 2 minus G of 1 over 2 minus 1. G of 2 is 256. G of 1 is 4. 2 minus 1 is 1. And so this comes out to be 252. And I shouldn't put equals there. I should make these squiggly lines because it's approximately equal to, right? This is an estimation. Now let's go ahead and find the actual value. All right, so to do this, we're going to need to use our derivative rule for exponential functions. So whenever you have a function that looks like this and you want to find its derivative, the derivative will be the same exact function as it originally was, times ln of a. However, there's going to be a chain rule associated here because we have this. There is the derivative of the exponent also. So after we apply this rule, we're going to multiply it by the derivative of the inside. And so let's go ahead and do that here. So the outside function is this exponential function, and the a in this case is 4. So the actual value of the derivative, let me write that out. The actual value of the derivative is ln of 4 times 4 to the x squared power. But since we have this inside function here, we do need to multiply by the derivative of the inside. And so if I want to evaluate G prime 1.5, then I need to plug 1.5 into all of this. And for that, you're going to have to use a calculator, obviously. So this is a calculator-based question. So let's go ahead and do that. And so after I punch all that into my calculator, I end up with rounding to the thousandths place. Or that's 10,000th place, but whatever. That. So now the question is asking us to take our estimation and to take the exact value and find the difference between them. So I just need to subtract 252 and 94.1048. And once again, I'm just going to use my calculator for that. And I end up with 155.895 if we round to the thousandths place. And there you go. So estimation using the table, actual method using the property of derivatives, and then subtract those two values. All right, let's go ahead and move on to question 3. All right, for this question, they want you to use your calculator to find the derivative at 3 different values, which on this problem is going to be 3.1, 1.5, and 0.4, and to put them in order from least to greatest. So notice that this is a calculator-based question, and so I would encourage you guys to use your calculator to find each of these derivatives. So for instance, let's say you have your function f of x. If you want to find the derivative at f prime of negative 3.1, here's how you will do it. You're going to press math on your calculator. Then you're going to press the number 8. And that will bring up something that looks like this. Okay, and whenever you get that up on your home screen, you're going to put your function in here. You're going to put x here, and you're going to put the number that you want to plug in here. Now, a few of you guys might have the old school calculators, so it doesn't look like this after you press Math 8. So you might have something that looks like this. In that case, you're going to put your function here. You're going to put comma, and then x, and then comma, and then negative 3.1. So you're going to find the derivative using your calculator for these three values, negative 3.1, negative 1.5, and 0.4, and just find out which one's the least to greatest and pick the right answer. It's really just a question to make sure that you guys know how to use your calculators to find derivatives. All right, let's go ahead and move on to question 4 here. Selected values of a function are shown in the table above or below. What is the average rate of change of f over the interval 5 to 9? So here's 5, here's 9. The average rate of change of a function is given by the standard slope formula, which would be f of your last point minus f of your first point in the interval over 9 minus 5. Okay, and so f of 9 is 6, f of 5 is negative 8, and 9 minus 5 is 4, so we end up with 14 over 4, which can be reduced to 7/2. Okay, and so that's how you find an average rate of change. Pretty straightforward. Let's go ahead and move on to question number 5 here. The graph of the function f is shown below. What is the average rate of change for this one? It's another average rate of change formula. We want to go from 10 to 100. The only difference is we have to get our data from a graph now instead of a table. So I need to know what is f of 100. I need to know what is f of 10. And I need to subtract those and put it over 100 minus 10. Well, here's where x equals 100. And the y value at that point, it's hard to say what that is, but I'm going to estimate it as 200. Then here's where x equals 10. And at x equals 10, the y value is 40. And then 100 minus 10 on the bottom there is 90. And so I end up with 160 over 90, which reduces to 16 over 9. And that's how you can find the average rate of change from a graph. Let's go ahead and take a look at question 6. Another average rate of change question, but this time instead of using a table or a graph, they just give you an equation. So, but doesn't change the basic formula. We still want to know the average rate of change, and therefore it's still going to be g of your last point minus g of your first point over those two values subtracted on the bottom. The trick here with this one is that we need to find out what g of 2 and g of negative 1 is, and the way we do that is simply by plugging those x values into our function. So if you wanted to find out what g of 2 was, you would just plug 2 into this function here. So 2 times 2 squared minus 3 times 2 plus 1. And that's going to be 8 minus 6 plus 1, which is 3. So g of 2 is 3. We also need to find g of negative 1, so I'll plug that in now. Got to watch your signs when you have negatives, right? So that's going to be 2 plus 3 plus 1, which is 6. That's just going to be 2 plus 1 on the bottom, which is 3. So we end up with negative 3 over 3, which is negative 1. So that's how you do average rate of change when you are working with an equation. So we've done it with tables, graphs, and equations. Move on to question 7. All right, guys. So the derivative of a function h is given by this equation here. And they also tell us that h of 2 equals 8. They want us to find the equation of the tangent line at x equals 2. To find the equation of a tangent line, you need an x value, you need a y value, and you need a slope. And once you have all those, you go ahead and plug it into this formula here. And then you're done. So obviously the x value is 2. We want to find the y value now that goes with that, and that's from right here. H of 2 equals 8. That means that when x equals 2, y is 8. The last thing I want to do is I want to find the slope. The way that you find the slope is by plugging 2 into the derivative. So I'm going to plug 2 into this equation here, and we get 2 squared minus 3 times 2 plus 4. And that gives me 8 minus 6 plus 4, which is 6. And so we're ready to write our tangent line here. It would be 6 here, minus 2 here, plus 8 here, and we're all done. Now, sometimes when you're doing a multiple choice test, it's very unlikely that they're going to leave it like this on a multiple choice test. So they'll probably want you to simplify it a little bit. So distribute and then combine like terms. So this is probably, if you were asked this question on a multiple choice test, it would probably look more like this answer than it would this one up here. But I've always just had you guys leave it like this in case you have a FRQ or something. But all right, let's move on to number 8. We're going to skip this one. The answer is B. And we're also skipping 9. The answer is B. But let's take a look at number 10. Here are some questions you guys can ask yourselves to help guide your thinking through this problem. So first of all, ask yourself, is it possible for the limit of a function to exist while the function is undefined at that point? In other words, is it possible there's no dot located at a spot, but the limit still exists? Next question, what is the definition of continuity? Does f of 2 have to exist in order for it to be continuous? And then the third thing I'll have you ask yourself is this. What is the relationship between differentiability and continuity? That was in our notes from last weekend, so you might want to look at that one. But answering these 3 questions will help you decide the correct answer choice for number 10. All right. Moving on to question 11, it says determine if the function below is continuous and differentiable. Or it says or differentiable. I think a better way to have worded this would have been, is it differentiable and or continuous? And the reason for that is because if a function is differentiable, it necessarily has to be continuous. Okay, but it is possible for a function to not be differentiable while being continuous. So we really have 3 possibilities. It's possible for our function down here to be differentiable, which means that it's also continuous. It's possible for our function to be continuous, but not differentiable. And it's also possible for our function to be neither continuous nor differentiable. Okay, so we have 3 possibilities for this function. And that's true for any function. So let's go ahead and take a look at this one. So to determine if this is continuous, we need to make sure of a couple of things. We need to make sure that the function exists at the junction point. We also need to make sure that the limit from the left of that junction point is the same thing as the limit from the right of that junction point. And all 3 of those need to be equal. If all 3 of those are equal, then we're in business. So first of all, let's find f of 1. F of 1 is going to be the spot where x can equal 1, which is here. So I'm going to be using that function to find f of 1. And I'm going to be plugging 1 into it. If I'm approaching x from the left, that means I'm looking for x is less than 1. So for that one, I'll be using the top function. And then to find where the limit from the right, I'm looking for where x is greater than 1, and that would be the bottom one again. So let's go ahead and simplify all these and see if they all are equal. So this one simplifies to -1. This one is 1 minus 3 is -2 plus 1 is -1. And this one, I wrote this wrong. This is a -5. This one's also -1. So as you guys can see, all 3 of these are equal. Boom. That means this function is continuous. Okay, now let's see if it's differentiable. Well, to see if it's differentiable, we're going to repeat this entire process again, but we're going to do it with the derivative instead. So here we go. First of all, let's find out what f prime is. The derivative of a piecewise function can be found by simply taking the derivative of each of the pieces. So the derivative of the top piece is 2x minus 3, and the derivative of the bottom is 4. Now, the tricky thing here is that still applies for x is less than 1. This still applies for x is greater than 1, but we may or may not be able to put the equal sign here, because if those two limits are not the same at that point, then it's not differentiable, and therefore we can't put equals 1 there. But that's what we're trying to find out, is can f prime of 1 actually be defined? So let's go ahead and find the limit as x approaches 1 from the right. And let's find, and notice I'm putting f prime here now instead of f. And let's also find the limit as x approaches 1 from the left for the derivative. Now, if I'm approaching f prime from the right, then I would be using the bottom piece. So the answer for that one is simply 4. I mean, I'll write the limit, but anytime you take the limit of a constant number, it's just that answer is 4. This guy here, we're taking the limit from the left, and so that would be the top piece here. So the limit as x approaches 1 from the left of 2x minus 3. So plugging in 1 to this piece here, I would end up with negative 1. And here the limit of 4 is simply 4. And as you guys can see, those are not equal. So we have a jump discontinuity for this derivative, which means that the derivative does not exist at this point. And therefore we would say that f of x is not differentiable. Okay? Now if this turned out to be equal, then we would be happy and we'd say, okay, it can equal 1, and we would say that f is differentiable. But since those weren't equal, it's no good. Now just as an extra side note, let's say that you are doing the first step where you're just working with the original function, you're finding the limits from the left and the right. Okay, so, and as you're doing that, let's say this one fails. Well, if this one fails, you're done, because that means the function's not continuous, and if a function's not continuous, it can't be differentiable either. So you'll never have a situation where a function's differentiable but not continuous. That's impossible. If a function is differentiable, it has to be continuous. So if you ever fail in step 1, it's over, and just say it's neither. Okay? All right, let's go ahead and move on to number 12. This says identify all the places where the function is not differentiable. Also state if the function is continuous at those points. So we talked over the weekend about points where a function is not differentiable. So you might want to get out those notes now and use that to kind of help refresh your brain. But anywhere that the function is not continuous, the function is not differentiable. So here we have a discontinuity. Here we have a discontinuity. And here we have a discontinuity. So all of those places are places where the function is neither differentiable nor continuous. So I'm going to put not continuous at x equals, and let's see what these numbers are. It's kind of hard to tell. 1, 2, 3, 4, 5, 6, 7, 8, 10. Looks like maybe it's 11. So negative 11 and 7 and positive 11. So the function's not continuous, and therefore it's also not differentiable at those points. Because once again, if a function's not continuous, then it's not differentiable. But it is possible for a function to be continuous and non-differentiable. And that happens in two different kinds of places. One place that can happen is here at a cusp. Another place that could happen is here when you have a vertical tangent line, when your graph basically gets vertical instantaneously. So we would also say it's not differentiable, but it is continuous, because there's no holes, gaps, or jumps there. But it's not differentiable at the cusp, which is x equals -5, I think. And it's also not continuous here at 3. And so there are 5 points altogether where this function is not differentiable. So that's the answer to the first question. It's not differentiable at -11, 7, 11, -5, and 3. But it is continuous for the bottom two, whereas it's not continuous for the top 3. So that'll be helpful for your question 12, hopefully. Let's move on to question 13. Well, we do all this hard stuff, and then we get a question like this. And that does happen on the AP exam sometimes. Sometimes you just get a little grace, and you get a little something a little easier. So this is nothing more than the simple power rule. You're just going to take this, multiply it to the front, and take 1 off your power, and you're all done. That's the derivative. Gotta love those kinds of questions when they come. Here's another one. Now this one has thrown students in the past, but once you get past the basic issue, you tend to do okay. The basic issue is we don't like having variables in the bottom when we want to do the power rule. So before I even begin, before I even take a derivative, I'm going to rewrite this. I'm going to leave the 3/2 there, but that x over 8, I'm going to bring it to the side here and make it a negative power. Okay? After that, we go ahead and do the power rule again, just like we did in the beginning. So you're going to multiply the -8 to the front. And when you do that, you just multiply it in the numerator. So that's going to be -24/2. And you're going to subtract 1 from the power. And notice that it's negative, so that means it actually becomes -9. Now we have some simplification to do. First of all, this becomes 12. Second of all, since that's a negative, we could slap it back down there in the bottom so it has a power. It's positive. And there's our final answer for that one. Let's go ahead and move on to number 15. Roots is another issue that requires us to rewrite it. So whenever you have a root, this value here is your base. This value here is the numerator of the power on that base, and this number here is the denominator of the power on that base. So the first step is to rewrite it once again, and then we're ready to take our derivative, where you take this power and you multiply it to the front. So I've got 3/4. And then we subtract 1 from the power. Now you could do it the old school way, where you just put 3/4 minus 1, get a common denominator, etc. But for me, I shared with you guys a shortcut a little while back on how to subtract 1 from a fraction. You basically just do the top number minus the bottom number, that's -1, and then you keep the bottom number the same. Now, there's 2 ways we could rewrite this. This could be the answer that you see in a multiple choice test, but they might also write it like this. They may choose to get rid of the negative power and make it a positive by moving the variable to the denominator. Another thing they might do is they might change it back into a radical, where the 4 is the root and the 1 is the power. So there's 3 different ways that this answer may appear, and I don't know which kind you can expect to see because it could be different every time. But there's that. And that'll do it for our second video, so hopefully that was helpful, and we'll see you guys later.